Hello friends, welcome to our channel Red's Info Hub. In this session we will discuss briefly about a small concept that is impact parameter, which we come across in alpha scattering experiment in Rutherford's atom model. Impact parameter. Let us see what is impact parameter. Yeah, impact parameter, it is denoted by letter small b. Okay, so this impact parameter, if you see here, in case of an atom, if we consider this is an atom, it's at center of the atom, positive charge is located at a small place called nucleus. Then if alpha particles, see, if you draw a line passing through the center of the nucleus, this is the line, and if an alpha particle is approaching the nucleus with velocity v, then the distance between the initial velocity vector and the nucleus, what distance, not just the distance represented like this, it is not the distance measured from here to here, which is nothing but the length of this line. The perpendicular distance between, what kind of distance? Perpendicular. This is not perpendicular distance. How to represent that? Let us see. So if you just if you draw a line along the direction of velocity, and if you consider this line which is passing through the nucleus, then the perpendicular distance between initial velocity vector and the nucleus can be represented as this distance. Means this distance. This is called as impact parameter. So impact parameter, how to define this? Write down, note down everyone. The perpendicular distance between the initial velocity vector and the nucleus is called impact parameter. Okay, yes, and it can be calculated by using a mathematical relation or mathematical formula. B is equal to 1 by 4 pi epsilon naught into Z E square by Ke, kinetic energy Ke into cot theta divided by 2, where let us see what is what. Here 1 by 4 pi epsilon naught is a constant or electrostatic constant, we can call it as. It is given by here, where 1 by 4 pi epsilon naught is a constant, its value is 9 into 10 to the power 9 units. From electrostatics we can understand its unit is nothing but Newton meter square per coulomb square, or simply you can write units. And Z is atomic number of the element or of the atom, given atom, and E is charge of electron, and Ke is equal to kinetic energy, right? And here in this cot theta by 2, this theta is called scattering angle, or angle of scattering. So by making use of these parameters, you can calculate impact parameter. Is it clear? So it is very useful while doing the numericals, and you have to have an idea about all these parameters, what is what. Right, done. Now let us do some numericals by making use of this relation. Let us take one question here. The question is let me draw the page side first to take the question here. So let me bring a question. Yes, the question is this. I think it has started. Just wait a second. Yeah. Yes. Let us see the question. What is this? So it is given that, and it is given that in Rutherford's alpha particle scattering experiment, what will be the scattering angle for which impact parameter will be zero? For which impact parameter will be zero? What will be the scattering angle? This is what we are asked to find. What is given and what you're asked to find. You have to understand first. Here you have to take the options also, because we are trying to understand how to do this kind of questions in NEET point of view or JE point of view. First option, let us take it as the first option will be theta equal to 0 degree. Second option 45 degree. Third option 90 degree. Fourth option 180 degree. Yes, in this case, how to find what is that? In Rutherford's alpha scattering experiment, what will be the scattering angle for which impact parameter is 0? Impact parameter formula you have to use. We know that impact parameter B is equal to 1 by 4 pi epsilon naught into what? Z E square by kinetic energy into cot theta by 2. This is the relation between scattering angle and impact parameter. Here, only scattering relation between scattering angle theta and impact parameter we want. Let us keep all these terms as constant. So you can say B directly proportional to cot theta by 2. B directly proportional to cot theta by 2. For what value are is equal to some constant into this? So when for what value of this B is equal to 0? So let's take B equal to 0. 0 is equal to all these constant terms into cot theta by 2 into cot theta by 2. So here let us take this as some constant, all these parameters as constant, some constant. Okay, here this constant anyway can't be 0. If you equate cot theta by 2 equal to 0, then what we will get? Cot theta by 2 is equal to 0 means theta by 2 is equal to cot inverse of 0. Cot inverse of 0 is cot inverse cot theta is cos theta by cosine theta, or cot inverse of 0 can be nothing but cos inverse of theta by 2 by sin inverse of theta by 2. That is for what value of cos, the value of theta can be 0. If you observe in trigonometric table, it will be 90 degrees. So cot inverse of 0 is 90 degrees. So theta will be equal to 180 degree. That means for the scattering angle theta equal to 180, impact parameter will be 0. This can also be understood by using this conceptual point. If this is nucleus at the center, if an alpha particle is moving along the line passing through the center, usually impact parameter will be measured from the center, right? If it is here, this will be B. But if the particle is moving along this line itself, line passing through the center itself, then impact parameter is 0. In such case, alpha particle will bounce back by an angle of scattering theta equal to 180. That's why this is that's why we got theta equal to 180 for B equal to 0. Yes, I hope you have understood this. Copy it down, and if you need it, just revise this and listen once again carefully and go through it. No need to actually work out this also. Just if you remember this conceptual point, you can directly get the answer. Next question. Let us do one more question based on this. Yes. Let me bring another question. Yeah, next question from this itself. Let me bring this. Yeah. So what is given here and what you are asked to find? Let us see what is given here. I hope it is visible now. And it is given that the impact parameter at which the scattering angle 90 degrees and z is equal to 79 and initial energy is 10 MeV is an impact parameter. What is the impact parameter at which the scattering angle is 90 degrees and z atomic number is 79 and initial energy of the alpha particles is what you call 10 MeV. So let us take the options also related to this question. So options, let me write the options here. First option is yeah, 1.137 into 10 to the power minus 14 meter, and second option is 1.137 into 10 to the power minus 16 meter. And third option 2.24 into 10 to the power minus 17 meter. And fourth option is 2.24 into 10 to the power minus 18 meter. These are the options. Let us see how to get this. We are asked to find impact parameter. Scattering angle Z and kinetic energy are given. So we know that B, impact parameter B is equal to, we know that, yeah, B is equal to 1 by 4 pi epsilon naught into Z E square by kinetic energy into cot theta divided by 2. So actually you have to note down what is given. That is, but otherwise directly also you can substitute while doing the need point of view. So it is equal to 1 by 4 pi epsilon naught value. You have to remember it is 9 into 10 to the power 9 units, and Z it is given as 79, and E is the charge of electron. It is 1.6 into 10 to the power minus 19 whole square divided by Ke. Kinetic energy is given as 10 MeV. That is 10 into MeV is mega electron volt. Mega means 10 to the power 6. Electron volt, 1 electron volt is 1.6 into 10 to the power minus 19 joule into cot theta by 2. Cot theta is given as 90 degrees. So 90 by 2. So on simplifying this further, what you will get? Let us see. Here 10 power 6, this is 10 power 7, and it gets cancelled. 10 power 2 remains here, and here 1.6 into 10 to the power minus 19 one term, and here two terms are there, one gets cancelled, and 1.6 into 10 to the power minus 19 remains. Cot 90 by 2 becomes cot 45. Cot 45 is 1, and by taking all this we will get this is equal to 9 into 79 into 1.6 into here this has got cancelled. Here one term of this got cancelled entirely here, and 10 power here 2 is there, 10 power minus 19 will be there, so it remains remaining term will be 10 power minus 17, 10 power minus 17. If you multiply this, you will get 1137 into 10 power minus yes, minus 17. What is this impact parameter? It is a distance in meters. But in the options, if you see 1137 terms are only two terms are there, but 10 power minus 16 means it should be 113 point something should be there. It is not there. And if you observe another option, 10 power minus 14, here 10 power minus 17 is there. If you want to write this as 10 power 14, then it becomes 16, 15, 14. Yes, you can write it as in terms of 10 power minus 14 terms, but minus 14 form. 1.137 into 10 to the power minus 14 meter you can write. Yes, this is the correct option. Is it clear? This is how you have to calculate the impact parameter by using the given data. Yes. I hope you guys have understood. Go through this once again, and let us meet in the next video.